Big weekend plans? Probably not. Other than there you are right there, balled up in the corner of your room. All right, moving on. I got circle O. I got circle O, everybody. I am going to do a quick review. What type of angle did I just draw? 20. What type of angle did I just draw? What is it?
Central angle?
Central. How do you know it's central?
Because vertex is the center.
Thank you. Vertex is the center. You doing something new with your hair?
No.
Little like Rico Suave. Pull it. Looks like you're pulling it back there a little bit. No? I don't remember it. Gel?
No.
Windstorm?
No, I fell asleep in my couch this morning, so that's probably it.
Okay. You ever seen a comb before?
Yeah.
Okay, just checking. All right, not saying you need it. It's something. Yes or no? Am I like losing it? Like the hairstyle looks new to me. No.
I think it's just like pushed back.
No. Yeah, it's put. Thank you, Brad. It's pushed back more. All right, thank you. All right, I'm not losing it. Yes, John. Thank you. That's called an inscribed central angle. Now I want to show you a new one today, where the center or the vertex goes to on the circle now. The vertex is on the circle. So let's go to our notes here. That's called an inscribed angle today. Inscribed. So everyone, just put a point somewhere on the circle. Put a point somewhere on the circle. Anywhere, it doesn't matter. So an inscribed angle is where the vertex is on the circle. The sides of the angle have to be chords. The sides of the angles have to be chords. So from your vertex that's on the circle, draw in 2 chords from it. And you have just created an inscribed angle. And let's call it ABC. So we're all working with the same letters. So do you see the difference of a central versus an inscribed now? No need to draw this. No need. This is my center. This is my center, everybody. That angle right here, would that be considered inscribed? No, why not? Is the vertex on the circle? Nope, okay. I just want to make sure you can see everything here. That's awful. That's not any better, but is that inscribed?
Yes.
Even though that's a diameter, is that okay? Yes, because a diameter is a chord, so that's okay. Inscribed? No, but it is? Central. Good. Do you remember how to find a central angle? What's the theorem? Central angle is always equal to its 19? Arc length, right? They're always equal to each other. Not the case for inscribed. Here's the theorem. How do I find an inscribed angle? It's not equal to the arc. It's equal to half its arc measure, all right? Half its arc measure. All right, so please make sure central is equal. Inscribed is half the arc. Half. All right, let's jump right into it. Let's do this. Nice fade. All right, angle A is 80, arc AC is 88. I need your help. Need your help. How can I find the measure of arc BC? I'm going to say something. Is it correct or incorrect? 180. 180 because BC is a diameter. So that makes a semicircle. 180. We good? Arc BC 180. You should be challenging me here. No. Is BC a diameter? No, why not? Doesn't go through where? Doesn't go through the center. That's just a chord. Plain old chord. No diameter there. So BC is not 180. So how can I find the measure of BC? What type of angle is 80 degrees? Angle A is what type of angle? Use your vocab now. It is inscribed. And usually I would find angle A by taking 1/2 of BC. Everyone agrees? Well, if angle A is 80 and I find it by taking half of BC, how can I go backwards now? If I know the angle and I'm looking for the arc. Mumu, what's your deal? Double it instead, yes. So once I have the inscribed angle to find the arc, I want to double it. So arc BC must have been 160 degrees. Because I take half of it to find the inscribed. So that's 160. Let's keep rolling around here. Angle B now, measure of angle B. All right, everyone, look at angle B. What type of angle is it? Central, inscribed. What do you got for me? Central or inscribed? 13? Inscribed. So now I go to my rule I just gave you. It is half an arc measure. What's its arc measure then, if I'm going to take half of it? 21? 88. Half of 88? 44 for angle B. Going too fast? Are we all right? We're going? Angle C. Also inscribed, but you don't need to know a darn thing about circles, do you? Do you get angle C? Could you take half of arc AB? You could. But do I need to? How can I find angle C without knowing a darn thing about a circle? Nah, I don't need to know a darn thing. Why not, Mahmood? 180 degrees in a triangle, right? And I already know two angles, so easily finding the third. Oh, do I really want to do that in my head? No, I don't. I don't know. What do you got? 56? All right, I'll take your word. 56. And my notes are right over there, so I could probably go over and get the notes too. And finally, how about arc AB? Measure of arc AB. A couple different ways you could do it. How do you want to do it? Arc AB. Your move. Two different ways. I want to hear both ways, but just one way right now. Oh, 6. Talk to me here. How can I find arc AB? Double its inscribed angle, which is 56. Perfect. I like it. Double 56. 112. Any other way I could have found it instead of doubling 56? Serena?
You can add 88, 160, and subtract it from 360.
360 in a circle. Subtract the 2. Good. Good. Everyone all right with this basic one here before I go on to the next one? Is anybody doing anything interesting this weekend? I try. I really do. I try. And if you told me, I would really try my best to act interested too. I would. All right. If you told me you were doing something, I really would act interested, even though you probably would know I don't care.
How about what are you doing?
Oh boy, what am I doing? The fun dad life. It's my niece's 4-year-old birthday party at Little Gym tomorrow night. So I'll be having a wonderful time there, bringing my 2 daughters. Hopefully I can sneak in and participate. You never know. Get on the balance beam or whatever the heck they have over there, the bouncy bounce, and see if Uncle John could sneak in. Let's see. That's really about it. A little low time here. Girls don't have any sports to go to this weekend, so a little low time at the car. Maybe I'll be in the corner of my room, balled up. Hopefully nobody bothers me. Just stay away from me. All right. All good? Any other questions, comments? Sorry, that wasn't exciting. Maybe next weekend I'll have more for you.
What is Little Gym?
I guess it's this place in Colony that's literally like a small scaled gymnastics place for like toddlers, and I guess both my daughters took classes there when they were like 2 and 3. You know, they sit in a circle, they do a big parachute, all the old, like there is a balance beam there. I think there's like some ropes they swing across. It's like a big jungle gym for little kids though. That's what it is. And it's indoors, so. All right, yeah, Little Gym. Good? Questions? We've got time. There we go. Thank you. That would have been devastating. All right, go ahead. I'll let you guys find angle ADB and ACB on your own. Should be no problem. They're both inscribed angles. And I want you to notice something about your answers. What happened with your answers? What do you know about both angles? Aren't they congruent? Both of them should have came out to be 62. Why were they congruent? Why? Paul?
They shared the same arc.
You took half the same arc, didn't you? All right, and you guys just figured out the second theorem today. If you have two, what type of angles do I have? Two inscribed angles. Paul, what'd you notice about these two?
They share arc.
Two inscribed angles drawn to the same arc. Anybody want to finish it? If I have two inscribed angles drawn to the same arc, they are congruent. Yep. All right, let's try this theorem out now in the next example 3. ABD, 6x plus 26. ACD, 13x minus 9. What's the measure of arc AD? Can we all agree those are both inscribed? And they're both drawn to which arc? DA. So therefore, by the theorem, what do I know about those two angles? They're congruent. Yep, they are congruent. So I can take 6x plus 26, set it equal to 13x minus 9. Two inscribed angles drawn to the same arc are congruent. Let's solve for x now. Go ahead. We get x equals 5. How can you find AD then? Measure of arc AD. Can someone get a plan here for me how to find the measure of arc AD? 9? Got a plan? How can I find AD if I know x? 5 by 2? So it's going to be 10. You do want to multiply by 2, Shannon, but I don't want to multiply x by 2. What do I want to multiply by 2?
Oh, the 13.
The inscribed angle, right? So now take x and do what? Plug it in, then multiply by 2. Good. So I'll just take the measure of ABD, plug in 5, 6 times 5 plus 26. Either one you plugged into, hopefully they were equal to 56. And then, yep, Shane is right. Take 56 and double it to find the arc. $112 again. 112. Any questions? I wish that was it, right? We're done with the theorems. Nope, got 2 more for you. Yeah. Find the value of xy in arc BC. What's arc BC? All right. Yes, ABD is a straight line and AB is a diameter. All right, just so you guys know that, so you don't have to assume it. All right, what type of angle is x? Let's get rolling. What type of angle do I have for x? Central or inscribed? Inscribed, so you know from today it's equal to half its arc. Ooh, look at the arc it's drawn to. AB. Anybody know anything about arc AB? If AB is if line segment AB is a diameter, how about arc AB? Jonah?
Its measure is 180.
180, and even for a bonus point here, not really. What type of arc? What do I call that arc if it's 180? Takes up half the circle. Semicircle. There you go. Good job. Way to redeem yourself from your homework. All right. So yes, I am going to take half of 180. So angle X is a right angle, 90 degrees. And that brings me to our second theorem today about an inscribed angle. It's written, I wrote it up here, but I don't like the way that's written. All right, I want to write it a different way. So inscribed angles drawn to, where's this inscribed angle drawn to? 2A, diameter, or you could use the word, anybody was going to use a different term? Semicircle. You can use either one. I'll use diameter. Inscribed angles drawn to a diameter, again, or you could have semicircle. Inscribed angles drawn to a diameter are what type of angles? Right angles. There you go. So in a proof, if you ever, maybe you need a right angle there to do HL or angle side angle. If it's inscribed drawn to a diameter, it's a right angle. All right, how about the rest? Help me find angle Y. You should know nothing about circles, needing to know nothing about circles to find Y. 16, how do I find Y? What's your go-to? Yeah, that's the easy way, right? Instead of trying to take half the arc, which I don't even know. 180 minus 90 minus 58. I don't know. 23. How's that look? No. How about 32? Not even close. 32. Is that correct? Okay. You guys wouldn't even tell me. You just let me keep teaching. See, that's the big difference between you and period 2. You guys are polite. If I wrote 22 down, even before I got the second 2 down, it would be, you are wrong. Good try in your mental math. Look who's still left in the Survivor game. That's all I'm saying. That's all I'm saying. Too harsh because they're not here? Too harsh? All right, and then last thing here, arc AB, arc BC, the measure of arc BC. All right, got to get it to me somehow. How can I find, with everything I know now, how can I get to arc BC? Thoughts? 5? Double it. There's a lot of its here, Greg. 32. There you go. Double its inscribed angle. Are you just ready to go every time I hit the button here, Greg, that it's going to be a 5 and you have the answer ready to roll? Because every time 5 pops up, I don't even say the number. Double it. You just have an answer ready to pop out.
Ever since my cosine.
Yeah, I know. We all know that. Yep. What's worse, that or the decimeter next to you? Were you here for that day? No? In a fraction, what's the bottom number called?
Oh, is that? I don't know.
Denominator?
Oh, yes.
Yeah, denominator.
Yeah, that's what he's saying.
That's why you guys are the worst pair in the nation. Yeah. All right, good. Last theorem I need to go over for you. Last theorem. Everyone draw a circle underneath this last theorem here in your text box there. Draw a circle. Put a quadrilateral inside it so all 4 vertices touch the circle. I don't care what it looks like, square, rectangle, trapezoid, and none of them. Put a 4-sided figure that touches the vertices in there for me. And label it A, B, C, D. All right, here's what this last theorem says today, the third theorem and final one. If you have an inscribed quadrilateral, the opposite angles are supplementary. In an inscribed quadrilateral, opposite angles are supplementary. So for my diagram anyway, angle C, angle A plus angle C equals $180. Same thing for angle B and angle D equals $180. Opposite angles are supplementary. Supplementary. All right. All right, let's use it and we'll call it a day here. GFE, arc GFE. Take a look. G to F to E. How can I find that arc measure? G to F to E. And look, I gave you the 86 for a reason. Talk to me, GFE. 23, thoughts? 4? 13, thoughts?
Let's do 86 times 2.
There you go. Double it because 86 is drawn to GFE. So take 2 times 86, 172. 172 degrees. And now what about angle F? I do realize it's inscribed, but now I can apply the theorem. 9, how can I find that angle F?
180 minus 6.
Yep, it's opposite the D, so it's opposite D, so I know I can subtract it from 180 because they're supplementary. Oh boy, here we go again. 94. 94 degrees, opposite angle, supplementary. All good questions? All right, I've given you time to at least get going with the homework. Get my 34 out of 34 on the transformation test. Come on up. Let's go. We got some business to take care of. This is a big one. Big safety here. 2 people getting voted out Monday.